Hello everyone, welcome back to Math First by Vishal. So as of now, on 4th April, both Shift-1 and Shift-2 of JEE Mains 2026 were completed. And it turns out in the morning shift, that is Shift-1 of today, there are some good number of tricky questions and also thought-provoking questions. But obviously, there are some questions which are very straightforward also. So as I already told in the previous video, I'm not going to comment anything on the difficulty level of the paper because for obvious reasons, the difficulty level of the paper depends on the individual student who is writing that paper, right? So let us not comment on the difficulty level. And as I already told in the last video also, I will not be discussing the entire paper and I'll be discussing only the questions which might make students think twice. And moreover, some questions are obviously formula based or directly straightforward, right? So I'm going to avoid those kind of questions. And the questions which are potentially important for JEE advanced preparation also, I'm going to discuss those kind of questions. Right. Let's see the questions. So let's see the first question for today. And this is the question from trigonometry, obviously. And this is a question which was already asked two times in the previous mains itself. Okay, so let's try to recall the formula and also concept of this one, so that if this question comes up again, we have to be in a position to write it immediately, right? So the first thing we have to notice here is we have sine 3 degrees divided by cos 9 degrees, sine 9 degrees divided by cos 27 degrees plus sine 27 degrees divided by cos 81 degrees, and there is a value of b given to you, and we have to find out the value of b by a. And the students who have already solved this question in the PYQ book definitely will solve the question within less than a minute because it's a direct answer if you remember the formula. So no problem. Let us try to see this again, and we always have a scope for improvement, right? So let us do that. First thing, each and every term here is taking a general form of sine theta divided by cos of 3 theta, right? Because if you observe carefully, each and every term here is exactly in the form of sine theta divided by cos 3 theta. Now the main idea here is to multiply and divide by 2 cos theta. Multiply and divide by 2 cos theta. Because if you do that, the numerator becomes 2 sine theta into cos theta, which is nothing but sine of 2 theta whole divided by 2 times of cos theta into cos of 3 theta. And then now the next thing that I'm going to do is I'm going to write this 2 theta in the numerator as 3 theta minus theta. I hope you're observing that. In the numerator, I'm writing 2 theta as 3 theta minus theta. Okay. And then the remaining part is 1 by 2 times of numerator is clearly like sine of a minus b. I'm going to expand it. That is sine a sine 3 theta into cos theta minus of sine theta into cos 3 theta whole divided by this will be cos theta multiplied by cos of 3 theta. Now, when you split this clearly in the first term, cos theta gets cancelled and the remaining value is going to be tan 3 theta minus of next here in the second term when you split it cos 3 theta gets cancelled and the remaining part is directly tan theta. So which means the simplification part of each and every term here is half of tan 3 theta minus tan of theta, where for the first term you just need to put theta is equal to 3 degrees, and for the second term you need to put theta is equals to 9 degrees, and for the third term you need to put theta is equals to 27 degrees. So let's do that, and let's substitute these values based on this formula that we have got. Look at this. Capital A is equals to first term is what? Half of. Now in the first term theta is what? 3 degrees, right? So it is going to be tan of 3 into theta will be 9 degrees minus of tan 3 degrees. This is the first term. And second term is half of. In second case, we put theta is equal to 9, right? So it makes it half of tan of 9 3 is 27 degrees minus of this is again tan 9 degrees. And similarly, plus half of. Now third term, we are putting theta is equals to 27, right? So it will be tan of 27 into 3, which is 81 degrees minus of this is tan of 27 degrees. Now if you take half common, it is very obvious now. that many of the terms will be cancelled out. That is plus tan 9 degrees minus 9 tan degrees plus tan 27 minus 9 minus the tan 27. So which will leave you only two terms after taking half common, that is tan of 81 degrees minus of tan of 3 degrees. Right? But if you observe carefully in the question, this tan of 81 minus of tan of 3 degrees is itself is given as value b, right? So let's put that directly. We get a is equals to half of b, but we need to find out b by a value here. So b by a will be is equals to 2. Okay? So as I told, question is not difficult. If you know the right idea, this will be solved in less than a minute. It won't even take more than a minute. Okay. And once again, I'm telling you, if this question comes again in the next sessions or in the future JEE advanced, which is going to be in May, you should know directly how to write down this value, half of tan 3 theta minus of tan theta, which is a very standard thing in this trigonometry. Okay. I hope it is clear. Let's take the next question. Given that f of x is a non-constant, so you have to be careful, non-constant and polynomial, moreover it's a polynomial, satisfying the given equation f of x is equals to, let me write down here, f of x is equals to f dash of x multiplied by f double dash of x. Moreover, one condition f of 0 is equals to 0 is also given to us, right? Okay, so the question is not difficult here, which only thing is it takes some time to solve this question. Okay, so you can treat this as a lengthy question. And yeah, so let's start doing it. First of all, the main problem with this question is we don't know the degree of the polynomial, because obviously you have to assume the polynomial, right? Before starting the question. Since the degree is not given, we can identify the degree by looking at this equation itself. Because if I assume the degree of this f of x as some n, okay, and we know that if the degree of the polynomial f of x is n, then the degree of f dash is going to be n minus 1, obviously, and the degree of f double dash of x is going to be n minus of 2. But clearly we have the equation as what? F of x is equals to f dash of x multiplied by f double dash of x, right? So which means this n value here should be is equals to n minus 1 plus n minus 2. I'm just trying to equate the highest degrees on both the sides, which will give us the equation n is equals to n minus 1 plus n minus 2. So obviously on solving this, you're going to get n is equals to 3. So which concludes the function f of x is a third degree polynomial here. Okay. And if I start taking the polynomial, f of x is equals to some ax cube plus bx square plus cx plus d. But one more advantage is they gave you f of 0 is equals to 0 already. So if f of 0 is equals to 0, directly you can say that d is equals to 0 because it passes through origin. So it won't have any constant term. So which means the four unknown values has been reduced to three unknown values. Now let's start doing the question, right? So we have finally concluded that f of x can be taken as ax cube plus bx square plus cx plus d. Okay. Now that comes the calculation part. That is the lengthy part here. So you need to take this. I'm sorry. Here this is d is equal to 0, right? So it is only ax cube plus bx square plus cx. Now the only thing that we can do is take this function f of x and substitute it here and equate the coefficients on both the sides. So which obviously takes some time and patience and also more importantly accuracy, right? So let's do that calculation part. This is ax cube plus bx square plus cx. This is f of x is equals to f dash of x. I'm going to write directly. I hope you'll understand 3ax square plus 2bx plus c multiplied by f double dash of x. So which means I have to differentiate this one more time, which will give me 6ax plus 2b. Okay. Now, first thing, I will equate the coefficients of x cube on both the sides. So, what is the coefficient of x cube on left hand side, which is clearly a, right? And I'm not going to completely multiply on the right side. I'm just trying to get the required terms here. So, on the right hand side, what are the terms which contains x cube, which will obviously give you 3a into 6a. Okay. 3a multiplied by 6a. And then clearly this is a cubic polynomial, which means a cannot be is equals to 0, obviously. So you can cancel it out. And finally, you get a is equals to 1 divided by 18. So you got one value, right? And then next thing, obviously you'll go for what? Equating coefficients of x square. So let's equate the coefficient of x square on both the sides here. So what will that the coefficient be on left hand side, which is clearly b? What about on right hand side? Coefficient of x square, one of the term will be 3a into 2b. Clearly you have multiple terms, right? So you have to be careful. Plus 6a multiplied by 2b. Okay, because this is how you are going to get coefficient of x square. So 3a into 2b plus 6a into 2b. And then finally, let's conclude here. And I can say that this b is equals to 6ab plus 12ab. And finally, what we get is here b is equals to 18 times of ab. So which means there is no use on equating the values of quotients of x square, because again you're getting the same condition, a is equals to 1 divided by 18. Okay. Now let's equate the coefficient of x terms on both the sides. Coefficients of x on both the sides. Left hand side it is c clearly. What about on the right hand side? Coefficients of x. Let's do the proper calculation. These two combinations will give you coefficient of x, and these two will give you the coefficients of x. So let's do that. C is equals to 2b into 2b, which is 4b square, and plus 6a into c. 6a into c. And so finally, we have one more equation here, that is c is equals to 4b square plus 6ac. So let's keep it aside. We need that later. And then finally, this is not over, because finally we need to equate the coefficients, I mean constant terms also on the both the sides, right? And very clearly on left hand side we don't have any constant term. So constant term on left hand side is 0. Whereas if you observe carefully on the right hand side there is a constant term, which is 2 into b into c, 2bc. So which means clearly we get b into c is equals to 0. B into c is equals to 0. So what happens if b into c is equals to 0? At least one of the two values, b comma c, should be is equals to 0. So let's see what happens here. We have to obviously check for both the cases. If b is equals to 0 is put in this condition, then what you get is c is equals to 6 into a into c. 6 into a into c, right? And then here, clearly you can take it to the right hand side and you get 6a into 6a minus 1 multiplied by c is equals to 0. But clearly here we got a is equals to 1 by 18, so which will make this not is equals to 0. That means c will be is equals to 0. So let's see what happens if if c is equals to 0, condition is kept, right? So if c is equal to 0 is kept in this condition, we get 0 is equals to 4b square plus 0. And finally, we get b square is equals to 0, implies b is equals to 0. So from here, we have very important conclusion. In either of these cases, either if b is equals to 0 or also c is equals to 0, we are arriving at the same conclusion that both of them must be simultaneously is equals to 0. So which makes our calculation part while integrating somewhat better. Okay, that's an advantage to us. Now let's write down the function f of x finally, because we have all the required unknown values. F of x is equals to ax cube. A is what? 1 by 18 times of x cube. And what is b and c here? 0 and 0. So which makes the function only 1 by 18 into x cube, right? Now look at the required part. Let's see the required part. The required part is integral 0 to 2 f of x dx, and then also plus we have to find out f dash of 2 plus f double dash of 2 also. But I think the remaining calculation can be done by you very easily, because it's a very simple function. You know how to integrate and differentiate and substitute the values, right? So as you can see, the question is definitely not difficult here, but it needs proper calculation, patience, and also accuracy to get the perfect score in this question. Nothing more than that, right? Let's see the next question. And this is a question from differentiability concept, and one of the interesting questions for the paper. Not difficult, just interesting. So let's try to analyze the question. There is a function given to you, which is sum of two functions here. F of x is equals to minimum of 2x square plus 3 comma 6x, and also mod of x minus 1 multiplied by cos of x square minus 1 by 4. So what I'm going to do obviously is I'll try to take this as two separate functions and I try to analyze differentiability of both of them separately here. So let me take this as some function g of x. G of x is equals to minimum of 2x square plus 3 comma 6x. Now you know what to do. If you want to find out the minimum of these two, you know what to do very well, right? First thing is you need to solve both of them and get the points of intersection. Solve these two. So let's do that. We get a 2x square plus 3 is equal to 6x. So 2x square minus 6x plus 3 is equals to 0, which will give us the roots as 6 plus or minus square root of 36 minus of 4 into a into c, that is 24, whole divided by 2 into a, that is 4. Now let's see what you're going to get here, which will be 6 plus minus, this will be what? Root of 12 whole divided by 4, right? And if you cancel out the common factor here, which leaves us 3 plus or minus square root of 3 whole divided by. So these are the roots of this equation here. And moreover, you can notice that both the roots are positive. So let us try to draw a rough diagram of this. So y is equals to 2x square plus 3. You know what to do. Just draw the graph of 2x square and shift it upwards by 3 units. And y is equal to 6x is a straight line passing through origin. And while drawing it, ensure that it is cutting the curve at 2 points, moreover, both in the first quadrant here. So let this be the first point and let this be the second point of intersection, right? But what is our question here? We have to take the minimum of these two graphs, right? So we know how to take the minimum of two graphs simply by taking whatever the graph is below the other. This is a graph, right? I hope you're able to notice this. So this is a shaded part is one which is required minimum. And very clearly you can see there are two sharp corners or sharp points on this graph, which makes the first function g of x non-differentiable at 2 points. And also we know the points as well here. So let's write down the conclusion here, right? So g of x is non-differentiable at 2 points, 3 plus or minus square root of 3 divided by 2. The first function we have got two non-differentiable pairs. Now let's start analyzing about the second function. So what's the second function here, which is clearly modulus of x minus 1, and let me take it as h of x function. H of x is equals to mod of x minus 1 multiplied by cos of x square minus of 1 by 4. So what is the thing that we know about cos function? This is always a differentiable function. So this won't create any problem for differentiability. But we know that this mod of x minus 1 is non-differentiable at x is equals to 1. So which means for this function, this x is equal to 1 is a doubtful point. Is a doubtful point. Don't directly judge it as a non-differentiable point. So let's keep it as a doubtful point because along with mod of x minus 1, we have a multiplying factor there. Right? And if you remember very well, in one of the previous videos I made, I gave you a small trick also how to find out if that point is going to be a differentiable point or not, right? So the thing is what, when you take this x is equals to 1, and substitute in this multiplying factor. Okay. So if you try to take this doubtful point x is equal to 1 and substitute in this multiplying factor, what you're going to get? Cos of 1 square minus of 1 by 4, which is clearly not is equals to 0. So on substituting the doubtful point in the multiplying factor, if that is not is equals to 0, only then you have to conclude that x is equals to 1 is a non-differentiable point. Okay. And that is the reason it just makes interesting here, because if you forget that point, you might lose the question here. And moreover, they might set you a trap also for these kind of questions. For example, first, if the question was something like this, mod of x minus 1 multiplied by sine of x minus 1, it's a clear trap here because when you have mod of x minus 1, clearly you might notice that x is equals to 1 is a non-differentiable point. But that is not the case here, because if you take this doubtful point x is equals to 1 and substitute in the multiplying factor, which is sine of x minus 1, if you observe, this is sine of 1 minus 1, which is sine of 0, which is equals to 0. So what is the logic that I explained in the previous video also? Whenever you put that doubtful point in the multiplying factor, and if that is becoming 0, then the doubtful point actually becomes a differentiable point. So if this were the question, then in this case it would have been x is equals to 1, which is a differentiable point. Okay, so be very careful here. I've already given you two examples in this, right? So this is one of the example where you might fall into the trap, and one of the question was in the previous videos also. You can go back and watch it. Right. So let's conclude with this question. In the case two, in the second function h of x, here clearly we have x is equal to 1 as non-differentiable point. So as you can see, for the total function f of x, we have 3 points which are 3 plus or minus root 3 divided by 2 and also 1. So clearly the two functions are in addition, right? And none of the points are coinciding. So which makes all these 3 points as non-differentiable points. All these 3 points are non-differentiable points. Okay. And once again, when you are getting doubtful points of first function and also doubtful points of second function, if any one of the value is coinciding, you have to verify at that point also. Okay, so be very careful. They might set you traps in the question. If one of the value is coinciding in doubtful points, for example, in the first function that we solved here, let's say you got x is equal to 2 as a doubtful point for differentiability. And similarly, in the second function that I have taken also, let's say you got x is equals to 2 as the doubtful point for differentiability. And since one of the values is coinciding here, you have to manually verify and then and then decide it is going to be differentiable or non-differentiable. Okay, so be very, very, very careful with continuity and also differentiability. Right? Let's take the next question. And this is an interesting question from the definite integration chapter. So let's see the question: integral minus 2 to 2 step of sin x plus modulus of x into sin x. So obviously you have to solve both of the terms separately. So let's do that. First I'll split it. Minus 2 to 2. This is a step of sin x dx plus again minus 2 to 2 modulus of x into sin x dx. Okay. Now here what I'm going to do is I'll take this as some value I1 and this as value I2, and I'm going to try to solve them separately here. Okay. The first thing, actually, if you know the trick here, I1 is very simple. Don't try to complicate while solving I1. It's a simple trick. Here, minus 2 to 2, step of sin x is there. And just to try to use the King's rule. If you use the King's rule here, you can just replace x with minus x on the right hand side, right, using King's rule. So I1 is equals to integral minus 2 to 2. This is step of sine of minus x, which will give you minus sine x here of dx. And simply add these two here. If you add these two directly, 2 times of I1 is equals to integral minus 2 to 2 and step of sine x plus step of minus sine x of dx. And we know the trick here. If you had solved this question previously, you know the trick already, that this can be replaced with minus 1. Even if it is discontinuous at some points also, you can split the interval and show that it is always minus 1 in that corresponding intervals. This is a trick. Directly you can replace that step of t plus step of minus t as minus 1 here. And that will give you directly 2i1 is equals to minus 1 into integral minus 2 to 1 dx. So if you solve this integration, you're going to get obviously 4. So 2i1 is equals to minus 4. I1 is equals to minus 2. Okay. I hope you found this trick interesting. If you know this I1 can be solved in a very simple way. Okay. Otherwise, you might complicate it. Now, let's see the second term here, that is I2. I2 is equals to, moreover here you can notice that this mod of x into sin x is an even function, right? So let's write it as 2 times of 0 to 2. 2 times of 0 to 2. Now, in between 0 to 2, clearly this x sin x is positive, right? So let's make it as x into sin x dx. Now you know what to do. This is u and this is v. You're going to use the by parts. That is 2 times u. This will be u integral v. That is x into minus cos x. Limits are from 0 to 2 minus integral 0 to 2. U dash is 1 and integral v, that is integration of sin x, is minus cos x of dx. And then finally you get 2 times of this will be on substituting the limits. You will get it as minus 2 into cos 2. And anyhow, second term is going to be 0. And then minus of minus plus integral 0 to 2. This will be cos x dx. Now you know what to do here. Integration of cos x is directly sin x, and the limits are from 0 to 2. If you expand, you get sine 2 minus sine 0, which is 0. So finally, it is nothing but 2 times of minus 2 into cos 2 plus sine 2. So which will give you what? Minus 4 into cos 2 plus 2 into sine 2. This is the value of I2. But in the question, what we need is I1 plus I2, right? Let's try to add these two and verify the final answer. I1 plus I2 is equals to minus 4 into cos 2 plus 2 into sine 2 minus of 2. Now let's see the required part here. They gave it as is equals to 2 into sine 2 minus 4 cos 2 and minus of beta, which means clearly here beta is equals to 2. Beta is equals to 2. Okay. So I hope the trick here was helpful to you. Okay. Don't try to complicate this one. The first that is calculating I1. Right. Let's see the next question. And this is one of the interesting question came in the morning shift here. It is based on functions and also part of inverse trigonometry. So let's see why it is interesting here. And if you do smart work in this question, you can save a lot of time actually. So I'll tell you what is the smart work which is involved in this solving. First thing is very obvious. Since it is a cos inverse function, you have to make sure the input is lying in between minus 1 to 1. So let's put that condition here, which will give you 4 into x plus 2 into step x divided by 3 lies in between minus 1 to 1. And you can cross multiply and you can get the condition as minus 3 less than or equals to 4x plus 2 into step x less than or equal to 3. So obviously whenever we have double inequality, what you're supposed to do, take both of them separately and then at last take their common part, right? So let's take them separately and analyze. The first part will give us the inequality something like this, which is 2 times of step x greater than or equals to minus 4x minus 3. And also, what is the second part here, which will give you 2 times of step x less than or equals to 3 minus of 4x. Okay. So obviously, you have to solve both the inequalities separately, and at last, you must take the common part, right? So it's obviously looking lengthy because step function is involved here. So one few students might think we can draw the graph of 2 into step x and the right hand side is obviously a straight line in both the cases and then take the inequality, take the region which satisfies the inequality. So which will be some time taking. Okay, so let's not do that. The smart work involved here is look at the options. Look at the options here. In each and every option, the interval is a subset of minus 1 to 1. That's the one thing you can notice, right? Each and every option involved there is a subset of minus 1 to 1 interval. Okay, that is why what I'm going to do is I'm going to split the cases here. Case 1, I'm going to take x belongs to minus 1 to 0. Okay, based on the options I'm going here. And if the options are not given, obviously you can draw the graph and or otherwise, if you want to solve it theoretically, you can take some cases and try to eliminate the cases which are not required. And just because the option, each and every option is part of minus 1 to 1 interval, and I'm choosing only two cases here, either x belongs to minus 1 to 0 or 0 to 1. And what is the reason behind that I'm taking only two cases, minus 1 to 0 and 0 to 1? Because it is step function involved, right? We know that step function breaks at what? X is equals to 0 in minus 1 to 1. That is the reason I'm breaking the interval into two cases. So let's call it as case A here. Case A is x belongs to closed minus 1 to open 0. And in this, we know that step x will be is equals to minus 1 whenever x belongs to closed minus 1 to 0. Now let's take it and substitute it here, and what we get is minus 2 greater than or equals to minus 4x minus 3. So finally what I get is 4x greater than or equals to minus 1, x greater than or equals to minus 1 by 4. But here x greater than or equals to minus 4, and also you should take the common part with minus 1 to 0, right? Because that is the case of what x belongs to minus 1 to 0. And finally, if you take the common part, you get x belongs to minus 1 by 4 to 0. Closed minus 1 by 4 to open 0 as your case A answer. Okay. So simultaneously, let's solve the second part also here for this case A. Same case, that is x belongs to close to minus 1 to 0. This implies step x is equals to minus 1. And if you put that here, what you get is 2 into minus 1 minus 2 less than or equals to 3 minus 4x. So finally, you get 4x less than or equals to 5, which is x is less than or equals to 5 by 4. But once again, you should not forget to take the common part of this with the original interval of case. So finally, what you get is x belongs to, and what is the common part of x belongs to close to minus 1 to 0 and also x less than or equals to 5 by 4? It is clearly close to minus 1 to 0. Okay. And then let's take the case B here. Let's take the case B. Do it very carefully. Case B, that is when x belongs to open 0 to close to 1. Let's take the case B, that is x belongs to close to 0 to open 1. Because in this case, you get step x is equals to 0, right? And let's take step x is equal to 0 and substitute back it here. Finally, what we get is 0 greater than or equals to minus 4x minus 3. So we get 4x greater than or equals to minus 3, or else we can say x greater than or equals to minus 3 by 4. And if you take the common part of this with the result that we get x belongs to close to 0 to 1, close to 0 to open 1. Okay, so this is your case B. So finally, the first inequality we have taken here has two cases, case A and case B. So which will give us the final answer for case 1. Okay. So for this first inequality, let's write down the final answer. X belongs to minus 1 by 4 to 0 union close to 0 to open 1. Okay, so this is your first case answer. And then let's solve the second part also simultaneously. And again, this is case B, right? When x belongs to close to 0 to open 1. In this case, we know that step x is equals to 0. Take it, substitute back in the original inequality, which will give you 0 less than or equals to 3 minus 4x. So from which you get 4x less than or equal to 3, or else x less than or equals to 3 by 4. And once again, don't forget to take the common part of these two here. Don't forget that. So if you take the common part of these two, you get x belongs to close to 0 to open 3 by 4. Okay. And finally, what is your aim? In the second inequality, you got two cases. You must take the union of these two cases, right? So which makes the second inequality final answer as x belongs to close to minus 1 to 0 union close to 0 to 3 by 4. Okay. Or else if you want, you can combine these two, right? If I combine these two directly, I can write it as close to minus 1 by 4 to 1. And if I combine these two, I can write this as x belongs to close to minus 1 to 3 by 4. Okay. So this is your first inequality answer, and this is your second inequality answer. But in the end, when we have double inequality, what is your aim? Take the common part of those two final answer. So let's try to take the common part of these two. So if you take the common part, what's your answer? X belongs to close to minus 1 by 4 to close to 3 by 4. Close to minus 1 by 4 to close to 3 by 4. So look at the options now. Close to minus 1 by 4 to close to 3 by 4, which is the option A. And also one more thing here. you might notice that in case B, I have taken only closed 0 to open 1. We still have one more value to check, that is x is equal to 1. But if you look at this original inequality, if you put x is equal to 1 here, what will you get? It is 6 by 3, which is 2. So minus 1 less than or equals to 2, less than or equal, which is not possible. So which means x is equal to 1 will not be in the domain. As you can see, I have taken only two cases here, close to minus 1 to 0 and close to 0 to 1. I missed the value x is equal to 1. And at last time, taking that and verifying that x is equal to 1 will not lie in the domain. Okay. So this is a better way to do this question. And if you are accurate and fast in calculation, this is not a difficult one. As I told, if you move option wise here, it is easy. Otherwise, lot of cases will be there, and you might think of graph point of view also. That will be again somewhat time taking. Okay, so this is a smart work which should be done by the student in the examination hall. Sometimes that is look at the options and then try to take your possible cases. Okay, so try to go through it once again. It's one of the interesting questions came in the morning shift. Okay. Let's see the next question. It is a question based on complex numbers, and it's not a difficult one, just a proper solving is required. So the first thing you can notice is the equation involving complex numbers. Modulus of z plus 2 is equals to modulus of z minus 2. And I'm going to rewrite this as modulus of z minus 2 is equals to modulus of z minus of minus 2. And what's the reason? Like we have the property, right? Whenever we have modulus of z minus z1 is equals to modulus of z minus z2. This will represent the perpendicular bisector, right? Perpendicular bisector of the segment joining z1 and z2. If you want, you can also put z is equal to x plus iy and solve. That's not a problem. Just I'm giving you the geometry part of this question. Whenever we have mod of z minus z1 is equals to mod of z minus z2, it will always, the locus of z will always represent the perpendicular bisector of the line segment joining z1, z2. So because of that, here you can notice this is z1, which is equals to 2, and z2 is clearly minus 2 here. And if you try to plot this, it is going to be something like this, because z1 is 2 comma 0. This is your point z1, which is 2 comma 0, whereas z2 is minus 2 comma 0, because it is minus 2, right? Now this is the line segment joining z1 and z2. Line segment joining z1 and z2 here. And as you can see here, the perpendicular bisector of this z1 and z2 is clearly the y-axis here. This is the perpendicular bisector in this case. It is very clear from the diagram itself. Y-axis is the perpendicular bisector. So which means the locus of this first equation is y-axis here, which means the point z lies on the imaginary axis here, not y-axis, imaginary axis. So the point z lies on imaginary axis, and that is the reason I'm going to directly pick z as some k into I, where k belongs to real numbers here, because I noticed that from the first equation, z is a complex number which is lying on the perpendicular bisector of z1 and z2 here, and that is the y-axis in this case, that is imaginary axis. So on imaginary axis, any complex number will take the form ki, where k belongs to real numbers. Now I'm going to take it and put that in the second condition, which will give me argument of ki minus of 3 divided by ki plus I, and I will take I common directly and write it as k plus 1 into I, and this should be is equals to pi by 4. Now you know what to do very well. If you multiply and divide by I, this becomes minus k, because I square is minus 1, and minus of 3I, and whole divided by, this is also minus of k plus 1, because you're multiplying and dividing by I, right? And this is equals to pi by 4. And finally what we get is here argument of, if you split this, it will be k by k plus 1 plus 3 into I divided by k plus 1 is equals to pi by 4. And clearly you can write down tan inverse formula here, tan inverse of 3 by k plus 1 divided by k by k plus 1, which is equals to pi by 4, and finally which will give you tan inverse of 3 by k is equals to pi by 4. So which makes it 3 by k is equals to tan pi by 4, which is 1, and hence finally k is equal to 3. And we have our complex number, that is z, which is equal to ki, that is z is equals to 3I. And at last, look at what is the required part here. We are just supposed to find out the value of mod z whole square, which will be exactly is equals to 9. Okay, I hope this is clear. Let's see the next question, and this is a question from probability, and this is one of the interesting question came from the shift 1. Let's read the question here. If a paid coin is tossed 8 times, if the probability that the first 6 throws contain 4 heads and last 5 throws contains exactly 3 heads is P, then we have to find out the value of 96 into P. Okay, that is the question here. So you have to do it very carefully because some cases will be there which you need to sort out. First thing, to be clear, I'll take the tosses like this: T1, T2, T3, T4, T5, T6, T7, T8. Let this be the 8 tosses here. And then what they are saying is this first 6 throws, which means this one. First 6 throws should contain totally 4 heads here. And simultaneously, what must happen here? The last 5 throws. If you count the last 5 throws, 1, 2, 3, 4, 5. So this last 5 throws must contain exactly 3 heads. Okay. So obviously there is a overlap of cases, right? That is T4, T5, T6 is overlapping here. That is why what I'm going to do is, first of all, I will try to decide how many heads are there in the tosses T5, T6, and what are the overlapping cases T4, T5, and T6, right? So let me write down number of heads in T4, T5, T6, because if I try to fix the number of heads in T5, T6, T6, and then I can distribute the remaining heads in the remaining T1, T2, T3, and also T7, T8 very clearly here. That is why let's make a table. This is number of heads in T4, T5, T6, and then number of heads in T1, T2, T3. Similarly, number of heads in number of heads in T7 and T8. T7 and also T8. Okay. So let's try to check the cases here. First of all, check whether zero number of heads is possible in T4, T5, T6. That is, there is no head in T5, T6, and T4. It's not possible, right? Because in T4, T5, T6, there is no head, which means that T1, T2, T3 has to cover 4 heads in total. So, which is clearly not possible. And that's the reason zero is not a possible case here. Let's eliminate that. Now, next case, there is exactly one head in T4, T5, and T6. Okay. So, first of all, if T4, T5, T6 is having exactly one head, which implies this T1, T2, T3 contains totally how many heads here? 3, because in total T1 to T6 it has to cover 4, and I told you that T4, T5, T6 is containing exactly one head here, which makes obviously T1, T2, T3 is containing the remaining 3 heads. And what about the other T7 and T8 here? In total T4 to T8 3 heads are required, but out of that already T4 to T6 one head is covered, which means this remaining T7 and T8 should have 2 heads remaining. Okay, and that is the reason this is the first case. Now I'll try to write down the combinations here, because out of T4, T5, T6, the head can appear in any one of the case, right? Any one of the tosses. So I'll try to choose that, which will give you 3C1. And here, 3 tosses T1, T2, T3, all of them must be heads, so 3C3. Whereas this here, number of heads in T78. So 2 tosses are there, both of them must be 2, so which is 2C2. So in this case, what's your answer? 3C1 is 3, 3C3 is 1, 2C2 is also 1, which is equals to 3. Okay. So try to observe this very carefully. if you understand the first case clearly, the remaining can be done by you. Okay, I will do it, no problem, but just to try to make sure you understood the first case. I'll repeat, absolutely no problem. So, first thing is, I'm trying to divide the cases here. The first column is representing number of heads in T4, T5, T6, and second column is representing number of heads in T1, T2, T3, and the third column is representing number of heads in T7 and T8. So first of all, I'm fixing number of heads in T4, T5, T6 as 0, which is not possible because if T4, T5, T6 is having 0 heads, then T1 to T6 cannot cover 4 heads. That is why case 1 is eliminated. Now case 2 is in T4, T5, T6 exactly one head is there. So if exactly one head is there in T4, T5, T6, then T1, T2, T3 must contain the remaining three heads, and similarly, T7, T8 must contain the remaining two heads. Now, why did we write 3C1 here? Because in any one of the tosses 4, 5, and 6, the head can appear. So out of three, you have to pick one where you have to put the head, which is 3C1. Similarly, T1, T2, T3, all the three tosses must contain the three heads. Picking 3 out of 3 will give you 3C3, similarly 2C2. Now, try to think what will be the next case. I will give you 10 seconds time. Think of the second case, next case possible. I hope you have got the idea. Now, I'll try to take two heads in T4, T5, T6. Now, which will give you 3C2 because picking 2 out of 3. 3C2. And then if there are two heads in T4, T5, T6, which means this T1, T2, T3 must contain the remaining two heads. So, which means out of three tosses, two tosses must require head. So, it should be again 3C2. And similarly, if T4, T5, T6 is having two heads, which means T7 and T8 must cover the remaining head, which is 1. So 2 out of 1, which is 2C1, so which will give you 3C2 as 3, 3C2 as 3, and 2C1 as 2, which will give you totally 18 as the next case answer. These are the number of possible cases. And similarly, think about the next possible case. Now again, take 5 seconds time. Try to fill that columns by using next case. I hope you have got the idea. Now, if I try to put three tosses in T4, T5, T6 as heads. Now, what is the meaning of that? If T5, T6, T4 contains three heads, which means T1, T2, T3 has to cover only one head, obviously. And then, what about T7 and T8 here? It should have zero heads, right? So, in this case, the combinations will be 3C3 multiplied by 3C1 multiplied by 2C0, because as you can see, if T4, T5, T6 is having three heads, obviously T7, T8 cannot have any more heads, right? That is why I wrote it as 0. That is why it should be 3C3 into 3C1 into 2C0. 3C3 is 1, 3C1 is 3, 2C0 is 1, so which will give you the answer as 3 here. Okay. So now let's try to count all the favorable cases here. So the favorable cases is equals to 3 plus 18 plus 3, which is equals to 24. Now, since it is a probability here, let's write down the probability. Probability is equals to 24 divided by, since you are tossing 8 points, it should be 2 to the power of 8. Okay, so this should be the answer, 24 divided by 2 to the power of 8. But what is the required part? They're asking us to find out the value of 96 into p. Now you can calculate the remaining part. Okay. So as I told, if you get the proper idea, you can do it easily. So getting this idea is very important, where you are taking three columns and trying to count how many processes are put in all the three columns separately here. So start from T4, T5, T6 so that you can put the remaining heads in the remaining process, that is T1 to T3 and T7, T8. Okay, as I told, it's very interesting question. So try to go through it once again. Okay. Let's see the next question. Now this is the question involving inverse trigonometric functions and also differentiation. So y is given tan inverse of 3 cos minus 4 sine divided by 4 cos plus 3 sine plus tan inverse of x divided by 1 plus square root of 1 plus x square. Okay. So we have to differentiate this function, and at the point x is equal to root 3 divided by. Okay. So if you get the proper idea, it's not a difficult one. Only the thing is proper calculation is required. It will take some time. Let us see what we can do. I can take y is equals to tan inverse of. Now I'm going to divide both the numerator and denominator with 4 cos x. Okay, I'll write it here. Divide both the numerator and denominator with 4 cos x, so that you'll be getting this as 3 by 4 minus of sin x by cos x, which is tan x, right? And whole divided by, this will be 1 plus 3 by 4 times of tan x. Now clearly you see a formula here. What is it? Tan inverse of x minus y divided by 1 plus xy, right? So which means I'm going to write this as directly tan inverse of 3 by 4 minus of tan inverse of tan x. Okay, this is the simplification part of this first term. Simultaneously, let's solve the second term also here. But to solve the second term, we need a proper substitution. As you can see in the denominator, we have square root of 1 plus x square, right? So whenever we have square root of 1 plus x square, we have to obviously go for the substitution. X is equals to tan theta. So let us do that. Let's put x is equals to tan theta. So the question changes to tan inverse of, this will be tan theta divided by 1 plus square root of 1 plus tan square of theta. Okay. Now you know what to do very well. That is how to simplify the denominator part, right? So let's simplify. This will be tan inverse of tan theta divided by, now root of 1 plus tan square theta is actually modulus of secant theta. You have to put mod of secant theta here. Don't forget that. And if you put theta, tan theta is equal to x, we get theta is equal to tan inverse of x, right? So since we are talking about this differentiation in the neighborhood of root 3 by 2, because you are putting x is equal to root 3 by 2 in the last step, right? So in the neighborhood of root 3 by 2, this theta is going to be obviously first quadrant angle, because tan inverse of root 3 by 2 is what? First quadrant angle. So let's take theta belongs to quadrant 1. And that is why mod of secant theta becomes secant theta. Don't forget that, because if the value is given as something else, accordingly you have to open the modulus, right? So be careful there. Now let's solve the second term carefully here. So if you try to solve the second term, this will be tan inverse of tan theta is nothing but sin theta divided by cos theta. In denominator, if you take LCM, you get 1 plus cos theta divided by cos theta. So cos theta gets cancelled, and the remaining part is only tan inverse of sin theta divided by 1 plus cos theta. But you know very well how what to do next, because the sin theta here is nothing but 2 sin theta by 2 and cos theta by 2. Denominator is 2 cos square theta by 2. 2 will be cancelled out, cos theta by 2 will be cancelled out, and you will be left with a simple term, that is tan inverse of tan of theta by 2. Okay. So let's write one more time the final part that we get, y value. So which is, so y is equals to tan inverse of 3 by 4 minus of tan inverse of tan x and plus tan inverse of tan of theta by 2. Okay. Now here, since we are talking the differentiation at x is equal to root 3 by 2, right? So root 3 by 2 is what? 1.7 divided by 2, which is 0.8. So which is clearly a quadrant 1 angle. So which makes this tan inverse of tan x directly as x. Okay. And once again, I told you, right? If the value was something else, then definitely you have to accordingly open this tan inverse of tan x function. Okay. So be very careful. And moreover, here we concluded that theta will be in quadrant 1 here. So which means tan theta by 2 also will be first quadrant angle. So tan inverse of tan theta by 2 again will be theta by 2. So finally what we get is y is equals to tan inverse of 3 by 4 minus of x plus theta by 2. But what is actually theta here? Nothing but tan inverse of x, right? So let's put that. One final step, that is tan inverse of 3 by 4 minus x plus 1 by 2 into theta is nothing but tan inverse of x. Now we need the value of dy by dx, right? You can differentiate. This is a constant. Differentiation will be 0 and minus 1 plus half of tan inverse of x differentiation is 1 by 1 plus x square. But we need this value at x is equal to root 3 by 2. Let's plug that value back here. X is equals to root 3 divided by 2. So which will give you 0 minus 1 anyhow minus 1 and plus 1 by 2 into 1 divided by 1 plus 3 by 4. And if you do the calculation, this will be minus 1 plus 1 by 2 into 4 by 7. So which is minus 1 plus 2 by 7, which will give you minus 5 by 7. Minus 5 by 7. Okay, so that will be the differentiation part. Okay. We just need to take care of few things in this question. Then it's going to be a simple question, not a difficult one, right? Let's see the next question. This is a question from Circles chapter. A circle passes through the point P 1, comma 2, and if two chords PS and P are drawn from the point P are bisected by the y-axis. Okay, this statement is important. Are bisected by the y-axis. Then the midpoint of R and S is alpha comma beta. Find the value of alpha 6 times of alpha plus beta. Okay. So the main thing here is what you need to draw the proper diagram, then you can easily solve it, but by taking a simple idea, obviously. So let's take the center of the circle, which is minus 1 by 2, comma 3 by 2, right? So center is minus 1 by 2, comma 3 by 2, and moreover it passes through origin also. So let's draw a diagram accordingly. It passes through origin and center is minus 1 by 2, comma 3 by 2. So just a rough diagram. Now they said that there is a point P 1, comma 2 on this circle here. Now a circle passes through the point P if two chords PS and PR are drawn from the point P. So let me take one of the chord first of all. I'll take one chord PS. Okay, I'll talk about PR later. So what they are saying is this chord PS is bisected by the y-axis. So what is the meaning here? Wherever this chord is meeting this y-axis, let's take it as some point Q here. They are simply saying that Q is midpoint. Q is midpoint of P and S. I hope it is clear. The diagram looks somewhat out of shape, so you can understand, right? So this PS is being bisected by the y-axis here, which means the point Q must be the midpoint of P and S. Okay. For that, what I'm going to do is first let me assume this point Q as some 0, comma K. 0, comma K. And then if you know this point P and point Q, and we know that Q is the midpoint of P and S, I can directly write down the point S here, right? The point S will be minus 1, comma, this will be 2K minus 2. If you use the midpoint formula, you will get this one. Okay. Now, very clearly, you can notice that the point S is a point lying on the circle, so it has to satisfy the given circle equation, which is x square plus y square plus x minus 3y is equals to 0. And let's substitute that here. So which will be 1 plus y value is 2k minus 2 whole square. And again minus 1 minus 3 into 2k minus 2 is equals to 0. So let's expand and see. And when anyhow plus 1 minus 1 gets cancelled, you get 4k square plus 4 minus of 8k minus of 6k plus 6 is equals to 0. So obviously you're getting a quadratic equation here. And you can understand, right, why you're getting a quadratic equation, because through the point P, you should be able to draw two chords based on the given condition. And since I have taken only one chord here, whose midpoint is 0, comma k, and just because you're getting a quadratic equation, it will give you two values of k, meaning two such points Q must exist as per the question here. Okay, so let's try to simplify here. What we get is 4k square minus of 14k plus 10 is equals to 0, or else it is 2k square minus 7k plus 5 is equal to 0. Okay, and I can write it as minus 5k and minus 2 and I can take common, right? It is k into 2k minus 5 and the minus of minus 1 into 2k minus 5 is equals to 0. So finally we get k minus 1 times of 2k minus 5 is equals to 0, implies k is equals to 1 comma k is equals to 5 by 2. K is equal to 1 and k is equals to 5 by 2. So now you can do the remaining part, right? Because what is the question here? The midpoint of R and S is alpha comma beta. Okay, so if you try to put k is equal to 1, you get the point S here because already we have got S value, right? S point, which is minus 1 comma 2k minus 2. If you put k is equal to 1, you get point S as minus 1 comma 0. Similarly, let's put k is equals to 5 by 2 now. If you put k is equal to 5 by 2, you will get minus 1 comma 5 minus 2, which is 3 here. Okay, but here this time this is other chord, right? PS is one chord, PR is other chord, so which means you must take this as a second point, second possible point R. So finally you have point S and point R, and given that midpoint of R and S is alpha comma beta. Now you know what to do. Find out the midpoint of R and S, which is clearly minus 1 comma 3 by 2. Now you know how to solve the remaining question here. Okay. So this is the easiest method for this question. So if you get the proper idea, it is not a difficult one, obviously. Just a proper idea is required at the proper time. Okay. Let's see the next question. And this is a question from 3D geometry involving lines. So let's read the question. There is a point A and line L1 and L2 both are given to you. We have to find out the distance of the point A, distance of the point A from L2 measured along L1. It's one of the previous questions also from the previous JEE main session. Just some numericals are changed here, and which is obviously potentially important for JEE advanced as well. So let us try to see it very clearly. So first thing, there is a point A. Diagram is important here, so try to be attentive. So point A is there, and then there is a line L2, something like this. Okay, let this be the line L2. Now let me mention the line L2 also, which is x minus 2 divided by 1 is equals to y plus 2 divided by minus 4 is equals to z plus 2 divided by 3. Okay. Now what we have to find out is the distance of this point A from the line L2, but we have to measure the distance along the other line L1. Okay. So let us take the line L1 to be somewhere here like this randomly. I'm taking. And L1 is the line given by x minus 1 by 2 is equals to y minus 4 by 4 is equals to z minus 0 divided by 1. So now the thing is you have to measure the distance of the point A from this line L2 along the line L1 means you have to measure the distance from A to L2 parallel to the line L1. This is the meaning, right? So if I draw a parallel line to L1, if that line is meeting the line L2 at point P, now you need to find out the distance AP here. That's the meaning of the question. Okay. So for that, some simple observations are to be made because already point A is given to you minus 2 comma minus 34 comma 6 here. And then clearly this line AP and this line L1 both are parallel to each other. And what are the DRs of this line L1? 2 comma 4 comma 1, which makes the DRs of the first line, when DRs of the line AP also as 2 comma 4 comma 1. Now let's write down the line AP here. Okay, line AP is a line which is passing through minus 2, minus 34, 6 and having the same DRs as L1, which is 2, 4 and 1. Now let's write down the line equation here. Okay, so line equation of AP is x plus 2 divided by 2 is equals to y plus 34 divided by 4 is equals to z minus 6 divided by 1. Okay. Now what we are going to do is I'm going to assume the point P here because if you want to assume any point on the line, you will take it as is equals to K, right? So from there, I will get the point P directly, which is 2K minus 2, comma 4k minus 34, comma k plus 6. Right. Now, what is the observation here? Clearly, this point P is also lying on the straight line L2 here, so which means it has to satisfy the line equation, right? So let me take this point P and substitute it here, which will give us 2k minus 2 divided by 1 is equals to 4k minus 34 plus 2 divided by minus 4 is equals to k plus 6 plus 2 divided by 3. Now let's solve it here. If you cross multiply and equate these two here, you get minus 4 into 2k minus 4 is equals to 4k minus of 32. And let's expand and see what is the value of k. So minus 8k plus 16 is equals to 4k minus of 32. Finally, what we get is 12k is equals to 48, right? 48, and from which we get k is equals to 4. Okay. So finally, we have got the value of k here. And why do we need the value of k? Because once you know k, you can substitute back in the point p to obtain it. So point p is going to be 8 minus 2, which is 6, and 16 minus of 34, which will be minus 18, and 4 plus 6, which is 10. So now you have the point p with you directly. And then you have the point A as well. Finally, you have to find out the distance AP as per the required question. So you can do the remaining solving part and try to verify, right? This is a proper idea to do this question. Try to be very careful here. Okay. Let's see the next question. And this is a question based on matrices and also involving counting cases, obviously permutations and combinations. So first of all, let's try to observe question. Set S is equal to set of capital A, where A is matrix A, B, C, D, and A, B, C, D can belong to the set 0, 1, 2, 3, 4. And then there is a matrix polynomial given to you, which is A square minus 4A plus 3I is equals to 0. And also, as I told, matrix A is already given to you, which is A, B, C, D. Now we have to find out how many elements are there in the set, yes, which means indirectly we have to find out how many such matrices are possible. Okay. So here the idea has to strike your mind that it's a pure concept of characteristic equation and also Cayley-Hamilton theorem application. Okay, because as you can see, it is a 2 by 2 matrix and it is a matrix polynomial satisfied by the matrix A. So once again, let's try to recall if you forgot. Whenever you have a 2 by 2 matrix, whenever we have a 2 by 2 matrix, we know the characteristic equation as lambda square minus k1 into lambda plus k2 is equals to 0, and where k1 here is nothing but place of the matrix A, and k2 is nothing but the determinant of the matrix A. And what do we know about the Cayley-Hamilton theorem? Every matrix satisfies its own characteristic equation. So which means this matrix A has to satisfy this characteristic equation, from which you get the characteristic means a polynomial matrix polynomial as A square minus of k1 into A plus k2 into I is equals to 0. Okay, so for a 2 by 2 matrix, this is the Cayley-Hamilton theorem, right? A square minus of k1 into A plus k2 into Y is equals to 0, where k1 is the trace of A, k2 is the determinant of A. And if you compare the given matrix polynomial A square minus 4A plus 3I is equals to 0 with the formula that we know from Cayley-Hamilton theorem, as you can clearly see, k1 will be is equals to 4, but k1 is nothing but trace of the matrix A. So this is condition number 1. Similarly, condition number 2, equate this remaining terms also, you get k2 is equals to 3, but here k2 is nothing but determinant of A. So you have two conditions, you have to solve both of them and check how many possible values A, B, C, D are there. Okay. Now let's use the condition number 1 first of all. What is the condition number 1? Trace. Trace must be is equals to 4. For the given matrix, what is the trace? A plus D. So let's equate A plus D is equals to 4. And also, what is our condition number two? Det of A is equal to 3, but what is det A here? AD minus BC, so which gives us AD minus BC is equals to 3. So we have two simultaneous equations. We have to solve, we have to check how many combinations of ABCD are possible. But ABCD must belong to only set containing 0, 1, 2, 3, 4. Okay. So now let's check for the possible cases here. Because if A plus D is equals to 4, you won't get many cases obviously. Because if I take the first case, okay, observe very carefully. First case, let me take A is equals to 0 and D is equals to 4, right? Because if A plus D is equal to 4 and ABCD can belong to only 0, 1, 2, 3, 4, one possibility is A is equal to 0, D is equal to 4. And this obviously implies the second equation changes to minus BC is equal to 3. This implies BC is equals to minus 3. But as per the given set ABCD, which is 0, 1, 2, 3, and 4, B into C is equal to minus 3 is not even possible. So this case can be directly eliminated. And in the similar way, even the case of A is equals to 4 and D is equals to 0 is also not possible, because if A is equals to 4 and D is equals to 0, again you will arrive at the same condition, B into C is equal to minus 3, which is impossible. And let's take the other case here, case number 3, that is A is equals to 1 and B is equal to 3. D is equal to 3. So let's check what happens with the second equation now. If A is 1 and D is 3, this equation 2 becomes 3 minus BC is equal to 3. This implies B into C is equals to 0. Okay. Now you have to count the cases. If B into C is equals to 0, where B and C must be taken from only this set, obviously one possibility will be 0, comma 0. And then if I try to put B as 0 as one of the case and C as a non-zero value, then how many possibilities are there for this second element here for C? Clearly one, two, three, four. All are possible. And similarly, if I try to take C as 0 and B as non-zero, in that case, B can be filled by 1, 2, 3, 4, which means you are getting one case here 0, comma 0. And here, four order pairs are possible when B is equals to 0 and C is non-zero. Similarly, when C is 0 and B is non-zero, four more cases. So in total, you are getting nine cases, nine combinations here in third case. Now let's take the next case here. Next case is the fourth one, that is A is equals to 3 and D is equal to 1. I'm interchanging that. And even in this case also, what's the advantage? You get the same equation, 3 minus BC is equal to 3, implies BC is equals to 0. And once again, you're getting the same equation, BC is equal to 0. Let's write down directly. You will get nine cases here, right? And one more last case is remaining. That is fifth case. A is equals to 2 and then D is also is equals to 2. So this implies this AD minus BC, which is 2 times of 2 minus BC is equal to 3, reduces to what? Let's calculate. B into C is equals to 4 minus 3, which is 1. But if B into C is equal to 1 and ABCD can belong to only 0, 1, 2, 3, 4, there is only one possible combination, that is 1, comma 1, no other possibility. So case 5 will give you only one answer, I mean one possibility. So let's try to check how many total cases we have got here. Nine cases here, nine cases here, one extra case in the last fifth case. So totally you get 19 combinations of ABCD as per the given conditions on the matrix A here. So clearly the 19 combinations of ABCD will give you 19 different matrices, and that is what exactly you're supposed to find out in the question, which is 19 elements in the set S. Okay, I hope it is clear. So these are the which I found interesting from the Shift-1. And if you found any other questions also interesting, please let me know in the comments so that I can make a video out of it. Right. So as I already earlier told, I didn't discuss all the questions, and so I hope it was helpful to you. And make sure you go through the previous videos also that I made from the 2nd April Shift-1 and Shift-2. And so when you go to your main session, you will be perfect with all the questions that came from the earlier sessions. Okay. And moreover, these questions are potentially important for the upcoming JEE Advanced also. So don't miss any of these questions. So try to go through it properly and try to watch the previous videos also, which I made on the previous shifts. And more importantly, if your session has already been completed, make sure you go through the top 10 PYQs videos, which I already earlier made, right? So that you will be ready for the JEE Advanced. Okay. So I'll upload the next video based on Shift 2 very soon. Okay. Thank you.